Hi everyone, welcome to the video lesson for Thursday, March 4th and Friday, March 5th. Today in class, we finally got to going from masses of one type of substance to masses of a different type of substance using our factor label method. Before we started those new notes and that new concept, we had a warm-up. Then we transitioned to our guided notes packet in our Google Slides. And then depending on how much time we had left at the end of class, we started working on the stoichiometry gizmo, part 1. No new work was assigned today in class. However, since you do have a 3-day weekend, I strongly encourage everyone to finish part 1 of the stoichiometry gizmo. And if you still feel like you could use some more practice, I will have also posted more practice problems in our module. Again, these are not for credit, but stoichiometry is something that you need to practice. The more you practice, the easier it does become. Today's warm-up looked a little bit different. I actually structured this one to look a little bit more like a quiz, kind of giving you a preview of our next checkpoint and how I expect you to answer that one. So our warm-up question was a mole-to-mole conversion, like what we learned about in our past lesson. Remember, warm-ups and checkpoints are always open note. I asked you how many moles of O2 will be produced if 6 moles of KClO3 are decomposed. Underneath the question, I've given you the balanced equation. 2 KClO3 will yield 2 KCl and 3 O2. So the first thing we need to solve for is to figure out my molar ratio. If I look at my KClO3, I see it has a coefficient of 2 in front of it. So I should select 2 moles of KClO3 are equal to moles of O2. So over here, I have 3 moles of O2. So I'll select the 3. Now I need to put all of this into my factor label grid. So my first box is always my given. In your question, you have a given and an asked for. Your given will always be a value and a unit, and what you are asked for will always just be a unit. So in this question, I have 6 moles of KClO3. That's a value with a unit. I'm being asked for moles of O2. I don't have a number of moles in my question. So 6 moles of KClO3 are my given. So I'm going to choose 6 moles of KClO3. Now, the rest of this question doesn't really matter for the next step, because remember, the key to these factor label grids is whatever unit you have here goes on the bottom of the next grid. You're always matching your unit at the top down. So here's mole KClO3. So I know right away my lower unit is going to be moles of KClO3. Now for my number, I've got a lot to choose from there. I'm going to come back to this. Let me figure out what my unit is here. Well, in this, I can either convert from moles to KClO3 to moles of KClO3, but that doesn't really make much sense, does it? Why would I convert from one thing to the same thing? Here in my equivalency statement, moles of KClO3 are equal to some number of moles of O2. So I'm going to put moles of O2 on top. That's also what I want to end with. I'm getting rid of my moles of KClO3. I want to end with my moles of O2. In fact, I've already put that as your final answers unit. So now let me get my amounts. I have 3 moles of O2. And I have 2 moles of KClO3. So now I just need to do the math. I have 6 times 3, so that would be 18. And now I need to divide by what's on the bottom. So 18 divided by 2 gives me a final answer of 9. When our warm-up was finished, I asked you to open up your Part 4 notes for Unit 6. Remember, if you haven't done so already, make yourself a chemistry folder in your G drive. Put all your Google Slides, all of your chemistry work into that folder. It'll make it much easier for you to pull those out and have them at the ready anytime you take a checkpoint or anytime we go back to the notes in class. I try to make these notes long enough that we're going to be going back to them more than once. Today's notes started on slide number 7. So to recap what we've done so far, we know how to convert between mass of a substance and moles of a substance. That's what we learned last week. I can use the molar mass in grams of something is equal to 1 mole of that something. We practiced with that. I hope we perfected it by now. Hopefully you've got an A on that checkpoint. And thanks to earlier this week, we know how to convert between moles of one substance into moles of a different substance. In order to do that, we find our molar ratio in the balanced reaction. We take those coefficients and make them equal to each other. And thanks to that third problem in the checkpoint, we also know how to do two-step or more conversions. All I need to do if I have more than one step in my conversion is I continue to cancel out those units I do not want by matching the units to the bottom right. Whatever unit I have is a unit I put on the bottom of the next grid. Then I look at my equivalency statements, see what can I convert it into, and convert it into a new type of unit. Now that we can do these 3 different skills, it's time to put them all together. On slide 8, I gave you your first mass-to-mass stoichiometry problem. You were given the following balanced equation. 2Fe plus 3CuSO4 will yield Fe2SO4 3 and 3Cu. If 10.10 grams of iron, Fe, are added to a solution of copper 2 sulfate, how many grams of solid copper would form? Now, an interesting thing is our very next checkpoint actually looks a lot like this question. You're asked to fill in the same things in the same places. So the first thing we're asked is to find the molar mass of Fe. So if I look up on my periodic table, Fe is iron. It's a very common metal. It's very stable. It's in the middle of the transition metals. If I look at its atomic mass, its molar mass is 55.85 grams. And remember, that is equal to 1 mole of iron. Next, we're asked to find the molar ratio from the balanced equation. So my iron, my Fe, has a coefficient of 2 in front of it in my balanced equation. And my copper, Cu, has a coefficient of 3 in my balanced equation. So my molar ratio is 2 moles of iron are equal to 3 moles of copper. And then our last thing before we start working on the factor label grid is to find the molar mass of my copper from the periodic table. Copper is also a very common, very stable metal. So it is also in my transition metals. Once I look it up, its molar mass is 63.55 grams. Now that we have all the equivalencies that we need, it's time to set up our factor label grid. Remember, we always start by putting our given unit in the top left corner. I have a value of 10.10 and a unit of grams of iron. So I've got my 10.10 grams of iron. Now you can use this as a wonderful map as to where to go next, but the most important thing you need to do is match those units. So if I have grams of iron to start with, I'm going to put grams of iron on the bottom. When I look at my equivalency statements, grams of iron are equal to moles of iron. So I'm going to put moles of iron onto the top. What I want to convert into goes into the top box. Now I'm going to add those units. I have 1 mole and I have 55.85 grams. Now I'm going to be ending with moles of iron, which is a problem because I don't want moles of iron. I want grams of solid copper. So I need to continue. Since I don't want to end with moles of iron, I'm going to put moles of iron on the bottom. If I look at my equivalency statements, I have moles of iron are equal to grams, and moles of iron are equal to moles of copper. Well, I just got rid of grams, so I don't want to go back to grams. So my only real option here is moles of iron equal to moles of copper. So I'm going to put moles of copper at the top. Now I've got 2 moles of iron to 3 moles of copper, so I'm going to put a 2 on the bottom with the iron, and a 3 with the copper on the top. Now I'm ending with 3 moles of copper. Well, that's still not what I want. I want grams of copper. So I don't want moles. I'm going to get rid of it by putting it on the bottom. Moles of copper, moles of copper. If I look at my equivalency statements, I have moles of copper, moles of iron, and I have moles of copper to grams of copper. So I'm going to convert my moles of copper into grams of copper. Take my numbers from the statement, so 1 mole of copper, 1 mole of copper, 63.55 grams of copper goes with grams of copper. Now I need to plug this all into my calculator. I'm going to plug in 10.10 times 1 times 3 times 63.55. Then I'll hit the enter button. And you shouldn't write down and re-enter what you get. Don't round before you have to. Your calculator doesn't round when you use the answer button. So please always use the answer button. Divide that answer by 55.85. Then click enter. Then take that answer, divide it by 2, enter. And then take that answer and divide it by 1. You're dividing by each of those values on the bottom, one at a time. And your final answer is 17.24 grams of copper. After we did that example problem together, I gave you some time to work on example problem number 2. In this problem, you were given the equation Mg plus 2HCl yields MgCl2 and H2. So how many grams of Mg are required to produce 23.0 grams of MgCl2? Once again, the first thing you're asked for is the molar mass of that given substance. In order to solve for the molar mass of MgCl2, we first had to look up the molar mass of magnesium, which is 24.31 grams. And then we looked up the molar mass of chlorine, which is 35.45 grams. But there's 2 of them, so I multiplied that by 2 and got 70.90 grams. When I add 24.31 plus 70.90, we get a final molar mass of 95.21 grams of magnesium chloride for every 1 mole of magnesium chloride. Part B asks you to find the molar ratio from the balanced equation. Well, there's no coefficient written in front of the Mg, so that means I have 1 mole of magnesium, equal to, I have no coefficient written in front of my MgCl2, so 1 mole of my MgCl2. And the last step before I can start with my factor label grid is finding my last molar mass of my asked for substance. 1 mole of magnesium is still 24.31 grams that you found earlier. In my question, my given value and unit are 23.0 grams of MgCl2, and I'll put that in the top left box. Since I'm starting with grams of MgCl2, the first thing I want to do is get rid of grams of MgCl2. My only equivalency with grams of MgCl2 is equal to moles of MgCl2. And then I'm going to take the values from that equivalency statement. I have 95.21 grams are equal to my 1 mole. Now I have moles of MgCl2 at the top. That's not what I was asked for, so I need to get rid of that unit. So on the next bottom of the grid, I'm going to plug in moles of MgCl2. Looking at my statements, I can convert that back into grams and be right where I started. Or I can convert that into moles of magnesium. So I'm going to convert it into moles of magnesium. And I'm going to take the values from that equivalency statement. Here I have a value of 1 and 1. So these cancel out. I'm currently left with moles of magnesium, which is not good. That's not what I want. I want grams of magnesium. So once again, I got to get rid of it. So on the bottom of the next panel, I'm going to put moles of magnesium at the bottom. Looking at my statements, I can go backwards, or I can continue to change it into a new unit. So here I have moles of magnesium are equal to grams of magnesium. Now I'll take my values from that statement. 1 mole is equal to 24.31 grams. So just double checking, all of my units have been canceled, divided by themselves, except for the unit I've been asked for, which is grams of magnesium. So to put this into my calculator, I have 23.00 times 1 times 1 times 24.31, enter. Then you want to divide that number by 95.21, enter. Divide that number by 1, enter. And then divide it by that last value of 1 on the bottom. Our final answer should be 5.87 grams of magnesium. This weekend, I'm going to make a separate video that goes over a few of the parts of that stoichiometry gizmo part 1. The beginning part of that gizmo really reviews older topics that we already know, like finding molar mass, finding molar ratio, converting between moles. So I will go over a few of those choice questions in a video. I cannot post those answers. Don't forget, interims are going out next week, so make sure you've got in all of your assignments so far. It looks to me like we've had about 4 homeworks, not including the warm-ups, and 2 all-task checkpoints so far. So make sure you've gotten those in. Make sure that grade is as good as it can be for your interims, so you can show it off to your parents. I hope everyone has a lovely weekend. I will see you guys in Zoom class again next Friday and Thursday. Stay safe and make good choices, everyone.